The volume of water, or the amount of water going down the stream, is measured over time. It's measured in units of cubic feet per second or in cubic meters per second. What that means is we can take a volume of water, a foot on each side of a cube or meter on each side of a cube, and say how many of those cubes of water are going down the stream over a certain amount of time. So in this case, seconds. So volume of water over time. That sometimes is hard to measure, so it is usually calculated as the cross-sectional area. So the area is squared. The area of the stream times the velocity, and velocity would be in something like meters per second. So area squared times meters per second give us meters cubed per second. USGS, U.S. Geologic Survey, measures the discharge of most of our big streams. The setup here in this image is showing you how that's done. This propeller is measuring the velocity of the water. This intake valve is measuring the depth of the water. And through those various measurements, they can get real-time data for how much water is in the stream over time. The velocity of the water is going to be different in different parts of the stream. The middle top of the stream usually has the fastest velocity. The edges of the stream are going to have the slower velocity because of friction between the water and the rocks, or the bedrock in the base of the channel. The wetted perimeter, it just means like how the size of the stream channel. So the image on the left is showing, turn this on. The image here on the left is showing like in a narrow stream like this, the wetted perimeter is 19 meters. Whereas if you spread a stream out, maybe make the water shallower and the channel wider, the wetted perimeter is 32 meters, and that velocity of that water is going to be slower because of the friction between the water and that wetted perimeter is it's a greater area. Most streams, though, are not going to be just straight and have that laminar flow like those pretty arrows show. Most streams are going to be pretty curvy. When that happens, when there's a bend in the stream, we call it a meander. The outside of the meander is termed the cut bank, and the velocity is going to be highest there. At the cut bank, there's going to be erosion because of that high velocity. On the inside of a meander, it's called the point bar. In this area, there is deposition because the velocity drops down. If you follow along in a river and find the fastest velocity where the most flow is occurring, that's going to be called the thaw weg. So this diagram is showing where the thaw weg is. It bumped from cut bank to cut bank. And then the inner part of the meander is the slow part, or the point bar. So streams have pretty turbulent flow. There's eddies, there's places where the water actually is moving backwards along the channel floor here. There's going to be twists and turns in the flow depending on the size of the boulders along the bottom. So it's never really going to be very much laminar or just straight flow.